Okay, now we're going to talk about component form. And the component form is when you use the letter I for your horizontal component and J for your vertical. So if you have the vector AB in standard form, so that means it starts at the origin and it ends at AB, which is also called sometimes the position vector. It can also be written like this. AI plus BJ. This is called component form. So the horizontal component is A, and you put that in front of the I, and then the vertical component is B, and you stick that in front of the J. Okay, now the way we can come up with our horizontal and vertical components, again, think back about triangles. If this is my vector V, here's my horizontal component A, here's my vertical component B. This is a 90-degree angle, which means we can use sine as opposite over hypotenuse and cosine is adjacent over hypotenuse. We can use all those rules that we did like in the first section. Okay, so if I know what my angle is and I want to figure out what my horizontal component is, okay, so I would use adjacent. This is, I'll label this as the length of vector V, right? This side here is the length of vector V. So I would have cosine of the angle is adjacent, which is A, over hypotenuse, which is the length of the vector. If I do some cross multiplication and I solve for A, then I get that A is the length of the vector times cosine of the angle. And this is just using our rules that we used at the beginning of the semester for right triangles. To find our vertical component, I would do the same thing, but I would use sine because we're looking at the opposite side. So I would do sine of the angle is B, which is our opposite, over our hypotenuse, which is the length of our triangle here, the length of the vector. And then again, doing some cross multiplication, I get that B is equal to the length of the vector times sine of the angle. So this is how you find what your horizontal and vertical components are if you need to. It's literally just, you could easily use Pythagorean theorem if you know all but one side, or you could use this trick here using the definition of trig functions using triangles. Okay, so getting more comfortable with component form, instead of giving you the vector as 3, negative 2 now, we're looking at it in component form, which looks like this. They're the same thing, just written two different ways. Okay, so we're going to sketch the vector 3i minus 2j, which means our terminal point, we're going to start at the origin, but our terminal point is 3, negative 2. So there's vector v. Our terminal point is at 3, negative 2. And if I want to find the magnitude, we're just going to use Pythagorean theorem. The magnitude or the length of vector v, we're going to take the horizontal component and the vertical component, make a triangle, and use Pythagorean theorem. Okay, so we're going to take 3 squared plus negative 2 squared. We're going to get 9 plus 4, and I'm going to get the square root of 13. Make sure that when you put this in on your calculator, if you're including the negative here, you don't have to include the negative here because when you square it, it should become positive anyways. But if you do include it, make sure you put parentheses around it. Otherwise, the calculator is going to think that you're doing this, which is -4, versus this means you're also squaring the negative so you'll get a positive. Is everybody doing okay so far? Any questions? Everybody's good? Okay. It says, let V be the vector from the initial point, -1, 3, to the terminal point, 2, 7, and we're going to write V in terms of I and J. So if I have point 1, where it starts at -1, 3, so right here, it starts there, and then it goes to 2, 7. If we want to write it in terms of I and J, we have to first put it in standard position. So if I imagine that this here is the origin, what would be my horizontal component? I'm going to come over this way and come up this way. Yeah, I'm going to have a horizontal component of 3. And then what's my vertical component? 4, right. And then I'm going to come up 4. So this will be my vector in standard position. So which means I would write it like this, or what the question is asking us to write it in terms of I and J. How would I write it in terms of I and J? 3i plus 4j. Yeah, 3i plus 4j. Okay, let's do this one too. Okay, we're going to have the initial point is at P1, which is -4, -4. And then P2 is at 6, 2. So it's going to come up like this. So I want to first think about what this would be in standard position. So I want to think of this point here as the origin. Okay, what would be my horizontal component? Yeah, 10. Right, from here to here is 10. And then what would be my vertical component?
8 or 6.
Yeah, 6. And then I can write it as 10i plus 6j. You guys got it? I don't want to scroll up too fast. Everybody got that okay? All right. Okay, now, this stuff is fairly easy too. I think so far this is fairly simple. When you want to do operations with vectors, like when you want to add or subtract or do remember what we call scalar multiplication when we multiply through by a number, you're literally just going to look at this. Imagine, it's not a polynomial, but you can kind of think of it as a polynomial when you're doing this. It follows the same rules. You want to add and subtract your like terms, okay? So if I have V and W and I got to add those, V is equal to 7i plus 3j, and I want to add that to W. Actually, I should put it down here. This is my V. My W is 4i minus 5j. This is my W. So I'm just going to add my like terms. They're my horizontal components. I'm going to add those together. and my vertical components, I'm going to add those together to get me my v plus w. So I'm going to add 7i and 4i, that's going to give me 11i. And then I'm going to add 3j and negative 5j, that's going to give me a negative 2j. Whoops. Not bad, pretty easy. Okay, for this one, v is 7i plus 10j. I want to stretch it out by a factor of 5 by multiplying by 5, and then I want to change its direction by multiplying by a negative. So I'm just going to take negative 5 and multiply everything by that, negative 5. There's my v, and I'm multiplying it by negative 5, so I'm going to get negative 35i minus 50j. So it's very intuitive. Okay, for this one, I want to take 6v, so I'm going to take 6 times 7i plus 3j, and I want to subtract 3 times w. So first we're going to distribute the 6 and the 3. So again, it's not a polynomial, but you can use the same rules like you're doing a polynomial, okay? So this would be 42i plus 18j. The thing with subtraction, though, remember you need to distribute your negative if you have a negative out here. So that's negative 12i plus 15j. And then when you add your horizontal components together and your vertical components together, you get 30i plus, let's see, 18 and 15, that's going to give me 33j. Everybody okay with these? Pretty straightforward, I think. Okay, now, there's something called the unit vector. Just like we have the unit circle, unit means 1, right? So a unit circle is a circle with a radius of 1. So whenever we think unit, we want to think about 1. So if I say I want a unit vector, that means I want a vector that has a length of 1, okay? So if I ask you to find a unit vector, but I want it in the same direction as some other given vector, what we're going to do is we're going to find the length of that vector, and we're going to divide that vector by whatever its length is, and that will create, it will keep the same direction, but it will have a length of 1. The notation for this, for unit vector, looks like this. You take the vector and you divide by the length of the vector. And sometimes, remember, the length of the vector sometimes in some books look like this. Sometimes it looks like a double absolute value. It could be either one. I'm pretty sure, if I remember correctly, our book uses just absolute value. Yes?
What's the double absolute value? What does that mean?
It means the same thing. Some books use the notation for the length of the vector with double absolute values. And I honestly, I think ours uses the single, but just in case I wanted to show you that symbol. But it means the same thing. It's just the magnitude, the length. Okay, so we need to find the length of vector v. So I'm going to take the square root and square each component, horizontal component plus the vertical component. Don't forget, if you're using the negative in there, to make sure you put parentheses. Otherwise, just leave the negative out because it's going to become positive anyways. Okay, that's going to give me the square root of 169, which is 13. If it doesn't come out even like that, just leave it as the square root of whatever it is. Like if it comes out to be like the square root of like 43, just leave it as the square root of 43. Okay, so to find the unit vector so that I have the same direction as this vector, but it's shortened down or lengthened out so that it has a length of 1. Okay, so we're going to take the vector, whoops, going to take the vector v, which is 5i, whoops, minus, where did I go? Here we go. 5i minus 12j, and I'm going to divide by 13, which gives me 5 over 13i minus 12 over 13j. So now my direction for both of these vectors, this vector and this vector, should have the same direction, but this vector should now have a length of 1. So let's check. If I take the square root of 5 over 13 squared plus 12 over 13 squared, if I did that right, we should have a length of 1. So that should give me 25 over 169 plus 144 over 169, which is equal to 169 over 169, which gives me 1, and the square root of 1 is 1, so it works. So this has a length of 1, but it's still in the same direction of this. How would I check to make sure that my directions are the same? What would I use? How do I find the direction or the angle of the vector? Do you guys remember?
Inverse tangent.
Yeah, inverse tangent. So let's do it. Let's check. If I take inverse tangent, we'll do this vector first. Inverse tangent of, let's see, I would take my y component or my vertical component, which would be, darn it, why does it keep doing that? Sorry, guys. I think I keep putting my hand at the bottom where the keyboard wants to pop up. Let's see, what will that give me? Inverse tangent of negative 12 over 5. Negative 12 over 5. That gives me a negative 67.38 degrees. If I want to put that in terms of a positive angle, so coming around in the positive direction, I would just add 360 to that. And I get 292.62 if we round to 2 places. Now, if I want to check, so that's the direction of this one. Let's check the direction of this one and make sure we get the same thing. Inverse tangent, I'm going to take my vertical component, which is negative 12 over 13, divided by my horizontal component, which is 5 over 13. I can cross off my 13s and I get negative 12 over 5 inverse tangent. And I get the same thing when I plug it into my calculator. So it has the same direction, but we just shrunk it down so that it has a length of 1. Everybody okay with that?